Jawaharlal Nehru Planetarium, Bengaluru welcomes you to demonstrations in astronomy. The actual diameter of our Sun is something like 1.4 million kilometers, and this huge ball of gas is something like 150 million kilometers away from the Earth. This distance between the Earth and the Sun is what is called as 1 astronomical unit. It is because of this huge separation that our Sun appears to be a small disk of half a degree in our sky. When we say half a degree, we are referring to the angular size of the Sun. Angular size means it is the angle subtended by the object at our eyes. So, our Sun subtends an angle of half a degree or 30 arc minutes at the eye of an observer standing here on Earth. But on other planets, how large would the Sun appear? What will be the angular size of the Sun on other planets? Now, let us see that with the help of this model. So, now what we are seeing here is the angular size of the Sun as seen from the planet Mercury. As we know, Mercury is the closest planet to the Sun. Mercury is something like 0.4 astronomical units away from the Sun. In comparison to this, our Earth is 2.5 times farther away from the Sun compared to the Mercury. So, because of this closeness, the Sun appears to be a little larger in size in the Mercurian sky. How much larger? The Sun appears to be something like 1.3 degrees in the Mercurian sky. Now, the second planet, Venus, it is 0.7 astronomical units away from the Sun. And at that distance, the Sun appears to be something like 42 arc minutes, slightly more than what it appears here on the Earth. And now comes the Earth. As I mentioned earlier, here in the Earth sky, we see the Sun to be something like half a degree or 30 arc minutes. And the next planet is Mars, which is at a distance of 1.5 astronomical units from the Sun, which is roughly 1.5 times more the distance to the Earth. Therefore, the Sun appears there slightly smaller. It appears to be having an angular size of 20 arc minutes in the Martian sky. And now comes Jupiter. So, Jupiter is something like 5 astronomical units away from the Sun, which is 5 times farther away compared to the Earth. So, it appears 5 times smaller there, and the Sun appears to be something like 6 arc minutes in the sky of Jupiter. The next planet, Saturn, is 10 astronomical units away from the Sun. So, therefore, the Sun appears to be something like 3 arc minutes in the sky of Saturn. Next comes Uranus, which is 19 astronomical units away from the Sun. So, the Sun appears much smaller there. It is something like 1.5 arc minutes in the sky of Uranus. And then comes Neptune, which is something like 30 astronomical units away from the Sun. So, in the sky of Neptune, the angular size of the Sun is something like 0.09 arc minutes. It is more or less like a dot. As we move from closest planet to the farthest planet, we see that the angular size of the Sun changes substantially. The closer the planet, the greater the angular size, and farther the planet, the smaller the angular size.